Okay, I'll start with the lesson. Okay, good morning, everyone. Please remember to key in your attendance. Okay, continue from chapter 7. Today you need to complete exercise 4 to 5, page 114. Okay, compare and interpret the dispersions based on histogram and frequency polygon. Okay, so from here, we know that uh, it is called bell shape. Okay, then compare the frequency and variable. Okay, this is bell shape, the shape of the bell, and then this is the shape of this is called uniform shape. That means very uniform. Okay, very constant. No, not too much ups and down. Okay, so for this one is a skew histogram. Okay, so skew histogram is called right skew, skew on the right, and this left skew means skew from the left of the graph. So to determine the distribution using hands, easier to identify the skew program. You can look at the diagram. You can look at the bottom of it. Okay, these two. If you put on your using your right hand, okay, this you see our fingers, my fingers over here represent the graph. Okay, so this is the graph. Okay, represent the graph. So this uh, the part where they skew to the right is smaller graph. Okay, you see smaller. Okay, the thumb here smaller. This one is uh, higher frequency from the histogram. Okay, the num part. So this is the thumb is skewed to the right. So when it's like that, the graph like this, that means the graph is over here. Okay, the thumb over here is a smaller, shorter histogram, so skewed to the left. Okay, our left side, this one to the right side. Okay, this using henna. Then other distribution, they are U shape. Okay, the U shape. This one is a J shape. Okay, then going up. Okay, different from skew to the right or to the left. Okay, this one from up then down. This one is from down to up. Down, up, then down again. So this one is called reverse J shape. Okay, this one is J. This one is reverse J. Okay, this one is called bimodal. Bimodal means up, down, up, down. Okay, not so uniform compared to this one, uniform shape. Okay, uh, you also need to refer back to the Form 4, Form 4 module. Okay, dispersion is how values of set of data are scattered. Okay, if the dispersion small, that means the data set has a small range. If the dispersion big, that means the range is bigger. Okay, that means let's say the graph like this. If this one is wider, that means the dispersion is larger, wider. Okay, that means biggest range. If it is shorter, that means smaller dispersion, smaller range. Okay, so for range, easier to calculate. Okay, for interquartile range, cases with outlier or extreme value. more appropriate measure of dispersion to show the distribution of the data. Okay, so in comparison, the range easier to calculate, but not so appropriate to choose it lah, to measure the dispersion. So look, interquartile range, if there's a cases of outlier or extreme value, means one value different far away from the other groups scattered, the cases scattered, data scattered. So standard deviation usually for compare two sets of data, okay, then they compare it with the mean, okay. If low standard deviation indicates the data is dispersed close to mean. If high standard deviation indicates the data is dispersed far from the mean. So we look at example 5. The diagram shows two histograms representing the time taken by 25 swimmers. So there are two diagrams. This one is a 100-meter backstroke, and this one is 100-meter freestyle. Okay. So A, state the distribution shape of the histogram for the two events. Okay, can you see this shape? It looks like a bell shape. This one is uniform shape. Okay, not much different between all the histogram, all the data in the histogram. So okay, it's a bell shape for 100-meter backstroke and uniform distribution for 100-meter freestyle. Okay, this is what we learned just now. So B, which event has a wider dispersion of the time taken? Give your reason. Wider dispersion. So is this wider? This one is 69.5 until 104.5. This one is 69.5 until 89.5. Looks like the 100-meter backstroke has a wider dispersion. Okay, so 100-meter backstroke event has a wider dispersion because the difference of time recorded is larger. That is 30 seconds between 102 seconds to 72 seconds. So this is the midpoint over here is 102. Okay, the midpoint over here is 72. So the difference is 30 seconds. Okay, because it's in second. So this is wider compared to here is 72 and here is 80, 87. Okay, so from here this is shorter. Okay, smaller dispersion. This is wider dispersion. The one wider dispersion. Then the reason is the time is recorded is larger. So C, between backstroke and freestyle, in which event did the swimmers perform better? Okay, so 100-meter backstroke and freestyle. If you look at the Olympics that finished early this month, okay, how do you know which one performs better? That means the one who can reach the destination faster. That means in a shorter time. Okay. So which one did the swimmers perform better? Which event? Okay. This one, number of swimmers achieve more on between 72 to 87. This one is the swimmers perform longer time from 72 until 102. Okay, takes longer time to complete. Okay, and most of it fair at between 82 until 92. Okay, that means they took longer time. They took longer time to complete this event compared to 100-meter freestyle. That means it looks like the swimmers perform better in 100-meter freestyle. So 100-meter freestyle, okay? This is because most of the swimmers recorded a better time. So example 6, the frequency polygon, okay, this is frequency polygon, just now it's histogram, shows the selling prices of the houses that were sold in two different areas in the last 6 months. Okay, the last 6 months, okay, not written here. That means for area A and area B, two different areas. So the thick one is area A, while the thin one will be area B. This is the selling prices lower in area A compared to area B. It means area B can sell a bit higher price. Okay, the number of houses, the house units around the same. It looks like around the same. Okay. So A, state the distribution shape in the two areas. Okay, like just now you have learned the left skew and right skew. Okay, so for this area A, okay, more than the knuckles, okay, the knuckles is like for area here, A is over here, and then skew to the right side, okay. So for area B is like this, okay, the knuckles over here, okay, skew to the left, to my left side, okay, to my left side, because from the video is the other opposite, okay. So this is my left, okay, so skew to the left, okay, because there's up and down, up, down, down, up, down, okay, different from the J shape, okay. So this now my answer, okay. So for area A is skewed to the right side and area B is skewed to the left, okay. B, compare the dispersions of the house price in two areas, okay. So I can see that area A, the prices is low, okay, while area B, the prices are higher, okay. The dispersion of selling prices A and B are approximately the same, even though the distribution shapes are different, okay. The dispersion, oh, okay, the dispersion is between here to here, okay. So you can compare the dispersion, okay. So this is here to here, okay. Here, what is it? Here, what is it? Okay. Here is 64.5. Okay. So you can use the calculator. Okay. 309.309,999 plus 344,999.5.5. Okay. Then plus add up together, divide by 2. I get 327,499 or 327,500 also can. Okay. Just roughly estimate lah. 327,500 lah. Here is 64995.5. Here will be okay. Okay, we can see the difference. Okay, you want to get the difference here between 99999.5 minus 64999.5. I get 35000. So the difference is 35000. So it's 64999.5 minus 35000. I get here is 2999.5. Okay, so I can this one add up together divide by 2, I get the midpoint. So plus 64999.5 divided by 2. I get here is the midpoint here will be 474999.5. So the difference you can calculate, okay, minus 327500, okay, is the difference for A is 28000. Okay, this is roughly figure only. Then for this one, okay, and this one, okay, this now is okay. So this one 37999.5 plus 35,000. Okay, roughly 379,999. Add up here by 2. Okay, add up no. Add up is this one is here will be add up 414999. So add up there by 2. Okay. Add with 379,999.5. Okay. There by 2. Roughly is around 293. Okay. You know, there is okay. How come? Calculate only. 35000 plus 379999. Okay. Is 414999. Then add up with 379,999.5, then divide by 2. So roughly is 397. Roughly here is 397,499 or 500 lah. Okay, easy. Then B is 397,500 minus this one. This one is you have to calculate 99999.5 plus 134,999.5. Okay, then divide by 2, you get 117,499. So 117,500. Okay, so you minus these two. Okay, minus 397,500. So around 280,000 also. Okay, so it's the same value. Okay, so the dispersion of the selling prices, okay, the dispersion of the selling prices approximately the same. Okay, no wonder it's the same. Okay, so you need to show the calculation also. Okay, so to compare how you know that the dispersion is same or not. C, in your opinion, which area represents an urban area and which area represents the rural area? Urban will be city lah, rural will be kampung lah. So rural here, more to area A because the selling price are lower. Okay. Then area B is for city folks. Okay, example KL. This one rural maybe like comparison lah. Taiping. Taiping the lower the houses are a few 100,000, but the KL is a few million. So in comparison, okay, you can see that A is rural area and B is urban area. Okay, because most of the selling prices are higher in B and most of the selling prices are lower at A. Okay, remember to key in your attendance.